Hello, good morning.
Hello. Unfortunately, we must wait several minutes. The technical problems. Good day. Unfortunately, we must wait several minutes. There are some problems with organization because we had photo session and there is problems with if you are here, the participant of conference. We have 5 minutes, not more. Yanis, before we began this our session, I'm very glad to recognize you. It's very pleasure to recognize you because of Latvia. This is one of the greatest Ukrainian support, and we are glad to see the member from Latvia in our conference. Dear friends, I'm chair of session mechanical manufacture number 1. My name is Vadim Stupnitsky, and I'm very glad to propose several reports with this session. Solution of Industry 4.0, sorry. We received the four reports. Unfortunately, we didn't receive reports from Milan Edley from University and of West Bohemia and the University of West Bohemia, same from Mitchell Zubik and company. Therefore, we have more time for this conference, for these reports. Sorry, for these reports. Usually, we propose for reporter about 10 minutes for just for report and for answer the question about 2 or 3 minutes, and but with this situation it will be we have a possibility to longer this your reports to the 15 minutes, not more. I ask for you. Therefore, first report is the member for Riga Technical University, Latvia, Jānis Pekša, automation data driver integration into ERP systems. Please, Jānis.
Thank you. Good morning, everyone. My name is Jānis Pekša. I'm from Riga Technical University from Latvia. I would like to present an automated data-driven integration to ERP system. Next slide, please. So the automated open data prediction framework architecture, what you can see here, was proposed several years ago as an approach to using an open data and other data available in companies using ERP systems to be able to use data stream tools and automated data transformations to be able to apply uneven distributed data in automated way by selecting the best forecasting models stored in a knowledge base for the predictions. As for example, there's a road maintenance during the winter season. There is necessary to predict a possible occurrence of the road conditions. The road sections will be like icing with certain probability, and in an automated way, the framework is able to recalculate and reformate the forecasting methods, as well as attract some cases additional methods that improve forecasting results, such as a use of common filter, automated prediction model search filling with the missing data, where the data points are not available or they are not existing at all, with some additional data points. As such, meteorological stations located next to the road section are not longer allowed to make very accurate predictions. External temperature and humidity indicators from near cities are taken as additional data sources. By configuring and modifying from the framework, the ERP system passed certain threshold values, which are specific cases are considered as the limit values in the event of the certain business process. In this way, without borrowing the ERP system and landing the capabilities of the ERP system outside the actual ERP systems. Next slide, please. So for this approach was bring those two questions as a resource questions. The first one, is it possible to connect the existing algorithms in ERP system? The second one, does the existing algorithms indicates the existence of the automaticity? So in this case, we are talking about this framework that I just described before. Next slide, please. So Broadway, looking forward to the literature review, there was certain questions was raised by basically understanding the complexity of data formats. So there's a little different kind of formatting. For instance, if you just take a date time, there are the formats around 20 to 30 different kind of types. If it's European, it's American, and so on and so on. Do you have seconds inside? Do you don't have them? Or you have only hours, and so on and so on. The next question was there by looking in the literature, can it actually work in real time? Means that, for instance, if the temperature from those meteorological stations just drop it like 3-4 seconds ago, let's say 1 second ago, can we actually handle this information, process the prediction, and actually get some outcome? And of course, we are talking about data security, that actually can you take those data, can you rely to them, is it secure manner, and so on. Data quality, of course, that I was mentioning about this missing points. So basically, what is the approaches and the methods how to fill in those missing points. Like, you know, if you have missing points, you can't actually predict nothing because you have undistributed data. And of course, the performance, where we are getting those capabilities from ERP system for basically that the business process not needs to be stopped because the server load is too high for getting those predictions. So that's why this framework is outside of the ecosystem of ERP system and can be managed and performed without those resources and affecting those business cases and scenarios that actually are in ERP system and that ecosystem. Next slide, please. So here's in this article a very simple example of overall the process is laid down. So basically we are considering of the company X that is a little bit different than a scenario for the road maintenance, and it's about selling products, basically using this ERP system, and how exactly we could approach those certain data, what we have in our system, in our ERP system, basically the previous historical sales, for instance, sales of some, let's say, commercial activities and so on and so on, and we can get those data inside the framework by, for instance, running, let's say, Google ad commercial, some TV commercial, some other website commercials, let's say, as an example, and we could understood are the big data is coming as a result to those sales. So this is very overall process of how it works in ERP system. Next slide, please. Regarding that one, a standard approach of UML was used to design this ERP system integration with the automated approach. So basically, it's very typical that you actually can use for any scenario within the ERP system. It means if you can provide this integration approach, and it means by maintaining it, reconfiguring, and so on, you're able to integrate with any external system, in this case framework, to ERP system. And this is how it was laid down as that approach. Next slide, please. And typically the SAP ERP system models are used like you see here. So actually ERP system is quite very spread around and in use in the world, and actually those models are already able to do a lot of different kind of things for prediction, for automated processes, and so on and so on. But those capabilities that, for instance, if you want to proceed with big data, then it actually takes a lot of resources, and it can affect also ERP business cases in some company. That's why this integration from dividing into the framework and ERP system side by side and creating this connectivity and getting just the results from the framework to ERP system, and ERP system as a business management system. Also, one of the models can provide, for instance, saying this result is bad. For instance, the sales drops, we can do something, or there's some icing on the road, and that scenario, we can send out the fleet by getting those chemical materials on the road section, and so on. Next slide, please. So after the analysis of the literature, it can be seen that there is a downside as our market, the performance issues, dependence of different forms, types of the reports, transaction data is not aggregated, data formal complexity, and availability of SAP ERP programmers is limited. So those are highlights here that actually what is able to have advantages for this framework integration into ERP system, because the framework itself is programmed and created in Python programming language. So it means that adapter, this programming language is not needed to be known, basically, and those programmers are quite limited nowadays. Next slide, please. So it was presented as a solution, so applying those SAP ERP models and integrating with the web service, so-called AODPF, and it's open source. It basically is published in the GitHub, so actually you can just copy it, put it as a web service inside, let's say, a container, multiply it, bring in your own, let's say, data inside, modify the forecasting methods that you wish to use or combination of them, and actually have this result in the end an integration with the SAP ERP system or any other system if you are able to put this integration bridge in between. So and basically this generates an automated manner with this one-day update of the results to ERP system that was provided during this research. Next slide, please. So in the conclusions, they're basically an answer for those two questions that was raised, the research questions. So the solution that the ABP programming language and the test code with the standard output during the experiment shows that acceptance from the web service to SAP system. As a result, information obtains and data integration has taken place, reflecting the experiment progress and implementation. As mentioned above, the answers for the first question, yes, it is possible to connect existing algorithms to the ERP system. And the second one, does the existing algorithms indicate the existence of the automated found? Answer should be marked as yes, but automation should occur every minute or not just once per day or maybe each second. Since this was designed as an experiment, it can be assumed that automation has worked perfectly. Next slide, please. Acknowledgement, this publication was supported by Riga Technical University doctoral grant program. And the next slide, please. Thank you for your attention. If there is any questions you wish to ask. Thank you.
Thank you, Yanis Peksha, for your report. And are there questions for this report? Next, if anybody have a question, I'd like to ask for you. Maybe better will be you propose there some examples for using this system in mechanical engineering, real results for using. Probably I missed the information. This maybe you proposed for us these results, but I missed it.
Yeah, thank you for the question. I didn't actually highlight those ones. I was just highlighting as this integration approach. And yes, there is several projects that this framework will be used. For instance, I was mentioning this road maintenance. This framework will be put in and transfer all those data from the meteorological stations and additional points to actually get an SAP ERP system and Microsoft Dynamics also ERP system, getting those results as a prediction. For instance, there is a law here in Latvia that within 2 hours you have to get clean road, the highways, right, from the icing, from the snow, and so on. But actually, with the predictions, you can get less than half an hour, saying that that specific road section needs to be, let's say, bring the chemicals on it. And with that point, you get about 90 minutes better result in the end. Of course, these results should be implemented in real life and calculated, and then I can say that's actually a good thing that happened. Thank you for the question.
Of course, of course. Thank you. Are there the next questions? No questions. Therefore, I'm very glad for this report and thank you for Yanis Peksha. I look forward that next our conference will be not online but offline, and we invite for you the invitation in Lviv Polytechnical National University. Thank you. Thank you. Next report will be from, this is from Portugal, Leonide Valera from University of Minho, yes, isn't it?
Yes.
The intelligent shielding system at architecture for manufacturing system based on I4.0 requirements.
Thanks.
Are you ready to
Yes, ready.
report? Please.
Okay.
We are waiting. Just a moment. Some technicals. Thank you. You can.
Okay.
Sorry, I said that we have additional time because two members for our members for this section didn't give your materials, and therefore you have more time, about 3-5 minutes.
Okay.
Thank you. You can to begin.
Okay. Hello, everyone. Nice conference. Thank you very much for this opportunity and for nice introduction of myself. So, as reflects this presentation is a work carried out by myself, some co-authors. I am Varela from University of Minho, and we'll share with you some insights regarding our research carried out for some time now in this work in particular regarding the state of the art and further insights. Okay. Are you listening now? Correct. Okay. So, as I was saying, I will present our work, which is centered on a main research question, which is realizing about the state of the art, about manufacturing schedule proposals, existing tools, platforms, and so on, which are now intended to implement special requests regarding Industry 4.0 features. Actually, this work has some similar aspects with the previous presentation provided by Professor Jenny. So we are in line, in fact, with some issues which are considered relevant nowadays in the current Industry 4.0 context. So the main purpose was twofold. On one side, realize about main characteristics, also features related to decision support systems and platforms for supporting concretely this situation, manufacturing scheduling decision support, also some other related aspects with manufacturing and management in general. It was twofold because a third study was carried out for realizing about the main aspects that actually have to be considered nowadays as important ones for supporting decision making and scheduling decision making in concrete. And it was carried out through a questionnaire that was distributed among a wide net of companies from Portugal and Spain. And through that questionnaires, we could, in fact, come across a kind of validation that our proposed characteristics that are important for the current Industry 4.0 are in fact important. Okay, so we realize that it is important to put forward platforms like one that we are proposing in this work. Okay, next slide. Next slide, please. Okay, thank you. Main aim was, as I said before, proposing a manufacturing schedule decision support system that can provide from new insights regarding the current challenges imposed for companies. More concretely, in this study, were analyzed companies from Portugal and Spain, but of course, this is valid worldwide. And thus we propose an architecture of the system that enable such requirements. Okay, next, please. Regarding the research methodology, as I said, we have distributed a questionnaire through a wide set of companies in Portugal and Spain, and we reached 198 valid questionnaires that were further analyzed, and it enabled to come across a proposal of a decision support system for satisfying more or less the considered most important characteristics and features of Industry 4.0 oriented manufacturing scheduling decision support system, mainly based on artificial intelligence approaches and tools and technologies, also further on characteristics, for instance, based on collaboration principles. Okay, next, please. So the main characteristics or features actually we came across in this study and which are related to Industry 4.0 are mainly related to integration aspects, horizontal and vertical integration of process and systems, also regard big data analytics, data science, the problems that were referred before also by Professor Dennis regarding storage, processing, and analysis of huge volume of highly diverse data which occur in manufacturing and management context. And further, also by aiming at including artificial intelligence-based technologies and approaches, for instance, related to machine learning and so on, and so integration aspects related to nowadays also well-known and that everyone talks about, of course, Industry 4.0 requirements related to IoT and for industrial IoT and RFID, cloud manufacturing, and so on, and also other aspects related to, for instance, to augmented reality, and mainly focus it on human-centered decision supports and the collaboration possibilities. Okay, next slide, please. Next, okay, thank you. So in this slide, we can see the main architecture models included in our proposed manufacturing scheduling decision support system. So we have a core model. You propose a core model that interacts and integrates some and communicates with some other models. For instance, for pre-processing data, which are gated through manufacturing systems, through RFID, the several kind of devices, so direct from the machines, from sensors and so on, actuators. And we have also another model, main model, which is directly connected to the core model for supporting scheduled decision support. This is a dynamic scheduled model, which on one side integrates a more automated model with machine learning approaches, and on the other side, we have a dynamic approach that is able to learn and improve a meta model. It is a kind of a meta model that learns, by example, provided by historical information that is getting historic from previous manufacturing decisions and information. And we also another proposed processing model, which actually communicates with the core model and indirectly also with the learning model, the dynamic scheduling model, for further processing multivariate time series, for instance, and also support the historical data for the feedback for the dynamic scheduling model. Okay, thank you. Next slide, please. So the main questions were included in the questionnaire. This was represented in this slide, which, as I talked before, integrate the question one about horizontal and vertical integration of processes and technologies. Question two about the need for big data processing and moreover in the context of data science and data analytics, further processing, also includes processing model. Machine learning mainly regarding artificial intelligence-based approach, and question four about the integration, the Internet of Things and cloud and RFID for the acquisition of data from the manufacturing system. Question five about the augmented reality processes and devices. And finally, and last but not least, human-centered decisions, importance of the human role in all this decision support system. Okay, thank you. Next slide, please. Here we can say some main results summarized in this table regarding these main questions that were forward to the companies Portugal and Spain. And as we can realize here, we have a variety from response 1, not important, to 0.5, which is important, undoubtedly an important feature of the system. And as we can see, mostly each of the questions or features that we can incorporate in our proposed decision support system for supporting manufacturing scheduling are considered of utmost importance. Okay, some companies are still a little bit confused with maybe the terms, the requirements underlying main features, and they are not they did not decide correctly, maybe, and pointed out 3 points. so they don't agree or disagree with the importance of the feature, but there is a clear focus and direction towards the concept about the importance of these features. So punctuate between 4 and 5, almost all these characteristics considered important, and mainly related with course integration, augmented reality also, but IoT and human-centered decisions. Okay, thank you. Next slide, please. So in terms of mean values and variations, we can see here that the main issues are in fact related with IoT, RFID, cloud factoring, and like, and also the integration, of course, it's fundamental. Everyone is almost now aware in companies that the integration is of utmost importance, of absolute importance. But also, it is nice to realize that the human role is also getting more visibility and importance. Okay, thank you. Next slide, please. Here, in terms of distribution of questions and the weights varying from one disagreement, complete disagreement, and complete agreement, 5. As I said before, we can realize, in fact, companies are aware nowadays, for instance, in Portugal and Spain, where the study was that all these aspects are in fact relevant and worth change and to perform transformative change to satisfy this 3440 requirement and improve these characteristics further in post regard manufacturing schedule decision support systems. As I said, main integration aspects, horizontal, vertical integration aspects, also IoT, cloud manufacturing, and the connection with the machines and the automatic acquisition of data from manufacturing systems direct from the machines is now, in fact, considered fundamental nowadays in industrial complex. It is worldwide, but the study doesn't prove this, of course. But okay, thank you. Next slide, please. In terms of the second part of this study out for comparing, in fact, the main characteristic proposed in this decision support system for manufacturing schedule and other more or less closely related ones as existing and referred in literature, the comparison did enable to realize that in fact, although there are some architectures already being for supporting these features oriented to Industry 4.0, mainly at least the most important considered ones, but there are others that are not yet so well positioned in this context. So is in fact important to continue the effort and to put forward decision support systems that include and consider these aspects as relevant ones, which is the case of the proposed one, which is the one that includes the 6 main characteristics here put forward. Thank you. Next slide, please. So in terms of main conclusions, we may say that it is worth, as I was saying before, to continue this effort and try to put forward worldwide more initiatives like this by proposing architectures that are now fulfilling the requirements of Industry 4.0. For instance, the ones related with artificial intelligence aspects, but also not lack the human role, because we are convinced that the collaboration aspects interfaces that enable human machine communication, not just for sharing information and communication purpose, but in fact for acting in an effective and efficient way the decision support in terms of manufacturing schedule. So this study was carried out, as I said, just in companies, Portugal and Spain, different industrial sectors, but more expertise still needed for expanding the study, of course, worldwide, and more examples to further validate and support this idea. Thank you. Next slide, please. These are some references. Okay, next slide, please. More references. Thank you. No, next slide. For what's supported here at the University of Minho, our the science technology. And the next slide. Next slide, please. Thank you very much for your attention, and I will be very pleased to answer.
Thank you, Ms. Valera. It was very interesting. Unfortunately, we have some problems with connection because I know that distance from Lviv and from your city is too far, but we have already understood everything, and thank you. Are there questions for this report?
Yes.
Unfortunately, we have a question, and I had a question about comparison with proposed system and the architecture of your report with existing. But after showing the slide number 11, my question is disappeared. Therefore, I have a question saved.
Okay, you can always email me or whatever you like, and I will be very pleased to provide that.
Yes, thank you. I'm very glad to recognize you, and I'm inviting you to Lviv. It will be very interesting for you, really, and we hope that next time we wait not by internet, but really.
Yes.
Thank you.
Thank you too. Thank you, and wish you continuation of a nice conference. Thank you very much.
See you again. Yes. And next. Next report, our report. This is from international comment from Austria and Hungary, but the reporter is from Hungary. Yes, this is Philip Rosenberger. The theme of this report is applicability of traditional project closeout approaches in agile developed IT projects. Are you ready to begin?
Yes, I am. Can you understand me clearly?
Thank you. You can begin.
Perfect. Do you understand me? Is the connection good?
Yes, we have.
Okay, good connection. Thank you very much. Thank you for giving me the opportunity for this presentation. And I want to use my additional minutes in giving you the bigger picture of my whole research project before I go really into the details of this particular article. Basically, what I'm trying to do in my PhD program is defining an optimized IT project management framework for agile developed projects. Optimized means I want to evaluate how people are doing their project management, how they are approaching it, and what they are doing and how much they are doing it. And based on these data sets that I'm currently collecting, I want to use a multivariate optimization and propose an optimized, for project success, optimized distribution of how to do your work, just as a proposal. So this is the big picture and the bigger research goal. And now please the first slide. Thank you. So as part of this optimization and development of an agile, applicable IT project management framework, which is optimized, I looked in this article that I'm now presenting at the closeout phase of projects, because I had a suspicion that an iterative and repeating and always developing and embracing change framework of Scrum and Agile development, which is 95% of software development at the moment, could conflict traditional, well-defined from the beginning project closeout of traditional project management approaches. So this was the basic idea behind it. And I thought, as Scrum is like a process that never stops, you're always having the possibility to add another sprint and continue working. It a little bit contradicts the traditional project management approach of defining a goal, defining a timeline, defining a scope, which is really fixed, and also a budget, and then just doing it until you're finished. And when you're finished, you do the project closeout. So I thought this contradicts each other, and I wanted to investigate if the industry of project management practitioners and also developers also have troubles in combining these two approaches. So how did I move on with this article? Next slide, please. The first thing I did, I did a literature research, classical literature research, trying to collecting the different definitions of project closeout, to-dos, and results. So there are several different traditional project management frameworks, and most of them define how, all of them define in some way, in some or another way, how project closeouts should happen and what the result documents of a traditional project closeout could be. Based on this literature research and the definition of project closeouts, I developed hypotheses, 3 different hypotheses about where the critical points when combining this with agile development, where these critical points could be. And based on this hypothesis, I did an online survey with 85 project management practitioners who participated in this survey, and asked them if they support my hypothesis or not. Next slide, please. So the first hypothesis is that agile development is a process and not a project, and therefore there is no indication of how to end this process. So Scrum has no end, for example. Therefore, my hypothesis is that it is unclear in agile developed projects how and when to stop, and which are the criteria to really stop this process of stop the project but continue maybe with further development. So this was the first hypothesis. The second hypothesis was that traditional scope fulfillment, so being done when everything is done, does not work anymore in agile developed projects, because there is constant change and flexibility within the backlog. So the backlog system always changes, new requirements, new user stories are inserted, old ones are deleted. So this is a constant change, and this scope fulfillment nearly never happens in agile projects. And the last hypothesis was that the transition between traditional projects and the ongoing agile improvement, maintenance of software to this process is unclear and can be critical. Because if you look at any software, there is always a start. Just imagine Spotify. A couple of years ago, I'm pretty sure a group in Silicon Valley sit there and said, we're starting the project of implementing Spotify. So they started a project, They planned it, they had the vision, they started working, and they never stopped. So at one point, this change from project Spotify is now somehow over to we continuously improve our software Spotify has happened. And my hypothesis was that it's very often not clear how exactly this is going to happen. So these are the three hypotheses I had, and I tried to verify. Next slide, please. So the results are, and my first question was, is the project closeout criteria clearly defined from the project start phase? And surprisingly, it was not as bad as I expected it to be. So 66% said, yes, we clearly know when and how to do the closeout and when this closeout will happen. The next result is, the next question was, which factor is the most relevant in triggering the closeout of projects? And also surprisingly, from my point of view, it was scope fulfillment. Although in agile development, scope is not fixed, it somehow is a clear indicator of a project closeout. The third question was, the magical triangle, as you all know, scope, time, and budget, changed since agile trends, as time and budgets are very often fixed in companies who are doing IT projects, but they allow flexibility because they want to embrace the agile mindset regarding scope. So they approach the project like, let's do the best we can with the time and the money we have. And I asked, this is changing because scope is more flexible now. And it was like 50-50 nearly. So it's 55% agreed, 42 disagreed. So there was not a clear mindset about this. And last but not least, the question, which was very specific, do you think that classical IT project management framework, next slide please, sorry. Next slide, please. Thank you. No, oh, sorry, too much. One back. Yes, thank you. Do you agree that the classical project management framework need an adaptation to handle these project closeouts in agile developed IT projects in a better way? And most, so my hypothesis was clearly falsified. Most of the participants said, no, the transition process is clear, it's really clear, maybe unidentified, but we don't really care, it's fine. So there seems to be no big problem in this field. So it seems somehow these two frameworks, these two mindsets and cultures, which are very different in their basic nature. The one is like planning and knowing and keeping a plan and keeping on the plan, and the other one is like learn on the way, embrace flexibility and let's see and hope for the best in some kind of way. So these two frameworks, they are not really contradicting in practice with each other. Next slide, please. So to put it in a nutshell, I think I already did it. So 88% as a conclusion, we could say, see the transition between agile, in agile IT project, the transition between the project and the ongoing process of software development, software improvement and maintenance as uncritical. And I also, it's not part of this article, the reasons behind it, but I had some interviews which, to be honest, not enough of them to really be significant in some kind of way, but I wanted to give you a quick implication why this is happening. And the main reason for this, for me surprising outcome was that they are not real, most of the projects are not really agile in a mindset. So most of them use Scrum as a development method, but basically most of them from the beginning already know what they're gonna do from the start on. So this strictly agile mindset of learning on the way and keeping the features open is not happening, is not lived in most of the IT projects. So very often it's like a combination of planning at the beginning, defining the product backlog, knowing what to do, and only then, like waterfall, and only then start in an agile, iterative way to get a little bit of change and flexibility within the development process. So the reason why this is happening is that the traditional IT projects are in a big part still traditional, and agile is just added as a way to implement software, as a way of the IT development doing its work, and not really the big agile mindset of starting at the beginning and keeping everything open. So basically, agile IT projects are not as agile as they maybe sound or call themselves. So this is like a little bit could be the reason, but I need to do more research about really finding out and having this new hypothesis confirmed.
Thank you very much, Mr. Philip. Unfortunately, we have a closer time for this report. Everybody know that management question is very important for successful realization of project, especially for this difficult branch as Industry 4.0. Therefore, we invite for you to Lviv and to continue your research with our researchers, and thank you. And last report. Thank you. Thank you very much. Thank you very much. And last report, this is a report from Italy. The reporter is Erin Rauch, three-dimensional technology radar model to evaluate emerging industry 4.0 technologies. And we ask for you to use only 10 minutes because really we have a special schedule, and therefore we have problems with time. Sorry.
Okay, no problem. Then I try to be quick.
Yeah, thank you. Maybe this is my mistake to say the previous reporter to make longer this report, and therefore we have some problems with schedule. Thank you. You can to begin.
Thank you very much. So good morning from my side. My name is Erwin Rauch. I'm an assistant professor at the Free University of Bolzano in the north of Italy. And today I want to present you our work that we have done also in collaboration with one company to develop a three-dimensional technology radar model for evaluating emerging Industry 4.0 technologies. So if we can skip to the next slide. Now let's take a look to the introduction and the major challenges. So what are actually difficulties of many companies when dealing with emerging Industry 4.0 technologies? So very often, first thing is that they don't have a huge catalog or an exhaustive list of emerging Industry 4.0 technologies. Second one is that they need also to understand which of these technologies are important for that what they are doing. If they are manufacturing companies, then what kind of technologies are maybe important for their products, for the manufacturing processes, but also maybe for their company processes or business processes. So they have difficulties to select and to assess these potential emerging technologies and to use this information then to define a strategy, a digital strategy or a technological strategy for the next 3 to 5 years, therefore a medium to long-term strategy. And if we go to the next slide, we see there the aims and technology clusters, because our aim in this research was to develop a technology radar that allows companies to do exactly that what we have seen before as a difficulty in a very pragmatic and in a very practice-oriented way. First thing that we had to do was also to see what are emerging technologies, what can we use as a basis for collecting a huge or comprehensive list of this kind of technologies. And we used, therefore, the Gartner hype cycle curve or the hype cycle reports, where in total over the last 3 years we identified and we collected 70 emerging technologies, and we tried also to categorize them in some different dimensions. So on the top level, you see these two top level dimensions, which are information-based technologies, where we have then as a subgroup artificial intelligence, digital platform technologies, and digitalized ecosystem technologies. At the other side, we have then more the ones that we can call the physical technologies, so automation, mobility, electronics, or material-based technologies, processes, as well as also immersive experience when we think about virtual reality or augmented reality, for example. So if we go then to the next slide, you see the approach that we tried to follow, because in a certain way we need also to give to the companies a methodology, how they can do this and how they can go through such kind of identification and selection process. And so we defined these 5 steps that you see on the slide. So the first step is to identify the technologies and to list them up, something that we already explained how we did this in our example. Then to select important or possibly important technologies. Afterwards, to do an assessment of these pre-selected technologies, giving us an overview of what is their impact or what is their potential for the future of that company. And to visualize this, in step 4, we developed this technology radar on 3 dimensions that I will show you later. And the 5th step is then to do a review on a periodical basis. So you will see then afterwards that we suggest here to do it at least every 3 years. But if you are brave in what you in updating your technological strategy, this should be done on a yearly basis. Next slide, please. So now going through these different steps that we have seen, there's the first step of technology identification. So we have already seen before that we need some database also where we can collect and where we can take all this emerging technology. So this is one of the important steps here, to have a comprehensive list of those and to have a possibility to say then that we want to go further with one technology or the other one. And in this phase, we used the Gartner Hype Cycle reports from the last years, which is 2018, 19, 20, where usually Gartner is reporting about the most important emerging technologies of the future. Next slide, please. So in the next step, then we need to do the selection process. And in our case study, together with a high-tech company near to Bolzano in Italy, we went through this comprehensive list of 70 technologies, and we tried to do a pre-selection together with a work group that did then also with us the assessment of these technologies in the next step. And in this work group, there was the CEO, there was the production manager, there was somebody from engineering, somebody from logistics, from the administration. Therefore, we tried to have a mixed and interdisciplinary group with all representatives of the different departments or functional units in this company. Going through this list and, let's say, in a very rude way, to list out those technologies where we are completely sure that they are not of interest for that company. Then going further to a next step. So if we go then to the next slide, we see step 3 with the technology assessment. And here we defined 3 assessment criteria. So the first assessment criteria is the maturity level, and information that we can get from the Gartner hype cycle curve. So usually in this Gartner hype cycle curve, we can follow emerging technology through these different phases, which is the first phase, the innovation trigger, when a technology is completely new. Then this peak of inflated expectations, where we think that we can resolve the biggest problems with these new technologies. So years before, for example, we had 3D printing, and we thought that 3D printing will completely be a revolution in the supply chain and in manufacturing. We know that most of or nearly all technologies go then through this disillusionment phase, where we see then, oh, not everything is possible to do with this technology. But in the next phase, we see, okay, with this next technological advancements and developments, there are some pretty good examples where we can apply this new technology. And then usually in the last phase, you reach this plateau of productivity, and you're reaching a level where you can then apply this technology also in industrial practice. So first of all, we used the Gartner hype cycle curve to determine the maturity level of these emerging technologies. But this is not enough to evaluate if going further with a certain technology or not. Therefore, we defined the enterprise value as well as also the deployment risk as a further criteria. In this criteria of enterprise value, we defined with points from 1 to 5, what is the impact on manufacturing, what is the impact on the operational areas in the company, what is the impact on the organization, and what is also the impact for going a step further in the digitalization of our company. So these are where this sub-criteria used for defining then the enterprise value. And in the third one, the deployment risk, we asked the people from the company about what is the resource allocation. Therefore, how much effort does the implementation of such a technology ask of us? Therefore, how many financial and personal resources we need to put in? How good we can integrate this technology in all the other technologies or business models that we are already running. How applicable is this technology? And what is the effort also to reach the plateau of productivity if we see there the chance that this technology will go into this phase of plateau of productivity in the next 3 to 5 years, or if it will be something in 10 years or 15 years? Please, next slide. This results then in a technology radar, in a three-dimensional one. So you see again here these 3 criteria: deployment risk, enterprise value, and maturity level. And based on this 3 axes, we can create this 8 quadrants in our technology radar, where we are focusing then on that one that you see here indicated with this arrow, which is the one for growth, where we have the highest enterprise value, where we have a very good maturity level. Therefore, we can implement this technology in the medium term at least. And at the other side, also with a low deployment risk. So these are the, let's say, the technologies with the highest priority. Of course, something that needs to be added, that also those technologies that have a high enterprise value, a low deployment risk, but maybe a lower maturity level, need to be kept in attention or under observation, because they can then develop to some further technologies that need to be seen with the highest priority. And with this, if we go to the next slide, we come into this last step where such a evaluation needs to be done in a periodical way. So for the company where we work together, we defined to do this exercise every 3 years, because after 3 years you can then update your last technology radar. You can see, okay, how the technologies have matured over the time, those ones that were selected 3 years ago, but also how many new technologies are now in this interesting quadrant. You see also how you should change also your strategy regarding technology evaluation and what kind of new technologies are now on the radar, and maybe also to delete from the list some of the technologies where you have seen in the last 3 years that it's maybe also too long to develop this technology for a medium-term use in this company. Next slide, please. Here you see then one picture. It's a limited overview of that what we can show you, because of course we have some privacy issues with the company. But to show you an excerpt of technology evaluations to see also how this looks. So it was implemented in a Excel spreadsheet tool that is now used internally by the company, and that we try, or that we offer now to use also in other industrial companies, where you can get the maturity level from the Gartner Hype Cycle, and where you define with these internal workshops the enterprise value, deployment risk, and you get then this total score and the 3D technology radar that helps you to define the technology strategy. Next slide, please. So to have a short discussion also, what is the contribution to theory? So there's still a lot to do, because there are some issues and limitations also with objectivity. Of course, we have to mention that the results are defined by a working group of 5 to 10 people in the company. Therefore, the objectivity issue is one that in the future needs to be addressed also when going further to develop a more sophisticated tool. But we have seen that for the contribution to practice, it was a really useful, helpful, and easy to use tool that was appreciated a lot by the company to go into this direction of a technology strategy. With that, I want to close also with the next slide. So for the concluding, it's a tool that helps us to reflect about current manufacturing processes and about new technologies. It helps us to define a guideline for technology strategies of the future. But of course, we have this issue of the evaluation performed in interdisciplinary workshops. That is a certain limitation due to the subjectivity of evaluations with 5 to 10 persons only. And with that, I want to stop also, because I see that otherwise I'm again over the time, over this 10 minutes. So I hope that I was briefly and short enough.
Thank you. It was really interesting report. And I know that Professor Ivanov have a long question.
Dear Erwin, hi.
Yes.
Nice to
Hi.
meet you
Hello.
again. Thank you very much for your last year's presentation. It was amazing, and today's presentation always beautiful. I have a very short question, and if you can, a brief answer. My question is, what will be the next stage in the Industry 4.0 implementation?
Oh, now we are opening really a big issue. But to make it short and to summarize it in a few words, so over the last 10 years, we have seen a lot of technological innovations with 3D printing, with digital data integration, with AI and so on. So for the future, I see a new level of Industry 4.0, which will be determined by data-driven and intelligence-driven innovation. So for the next 5 to 10 years, we would need to use all the technologies that have been developed over the last 10 years and before, apply also this chance of artificial intelligence and maybe also biointelligence with the biological transformation, which is coming more and more as a new trend also. Therefore, to learn from nature and to combine this phenomena from nature with AI and with the mathematical models that we know from computer science. And I guess that this could help us a lot to go from a smart factory that we have achieved maybe after the last 10 years, going towards an intelligent factory in the future.
Thank you very much.
Thank you.
Thank you.
It was really interesting, and we invite you to use in our programs as a professor, visitor professor in Lviv Polytechnical, maybe in another university. It was really interesting.
I'm looking forward to come in person next year to the conference.
Thank you. Thank you. See you again. I'm sure that the next hour meeting will be not online but offline. See you. And for this, our section is over. Next session will be in 1.5 hours. Yes, 1.5 hours. Thank you for participation for our conference, for our section.
Yeah.